Okie dokie do. Let's one sec. I'll make sure things are available properly. Okay. So hope you guys can hear me, everybody. Hi. Hello. Good morning, all. Good morning. Hope you guys are doing well. Enjoying or good evening. Right. Hope you guys are doing well. Let's get started. Going back to our TryHackMe. Yo, Wrench is also here. What's up, bro? My man Rover. Okay. Huh? भाई तो तभी है. Okay. So let's focus on getting our TryHackMe because stars 5, 6, and 7 are. Oh. Gotcha. I have no idea of trends, man. Oh, yeah. Bro, it's stupid. So, like. Yeah, let's lock in because we can complete this room fast. And then I want to show you guys something from the sponsorship I was looking through. Yeah, I know. It's crazy, man. It's crazy. People up here, honestly, this generation, at least in India, have lost their mind. Majority of them have lost their mind. But what do we care? We care only about hacking. Hacking Monday, hacking Tuesday, Thursday, Wednesday, Friday, Saturday, Sunday, Monday. Every day hacking. That's all we care about. We don't care about trends. We are the trend. Okay. So let's start with task 5 routing, which is, I think, it's very important because that's all networking is all about, right? Yeah, hack the planet, man. That's exactly what we're looking for, right? So, yeah, let's get started. And I want to share like something after the stream about the sponsorship, and maybe we can create something. We do something interesting about it, right? So remind me before I end the stream about the sponsorship. But first, we'll focus on completing this room because this the reason why I'm saying to remind me because this sponsorship is pretty big. I was looking through the numbers. To a level, right? If individually, right, every person can contribute up to $100 or more in this sponsorship, and there's so much more, so much more. So we'll talk about that. Okay. Till then, let's get into task 5 routing. Consider the network diagram shown below. It only has 3 networks. Yep. It only has 3 networks. However, how can the internet figure out how to deliver a packet from network 1 to network 2 or 3, right? Although this is an overly simplified diagram, we need some algorithm to figure out how to connect network 1 to network 2 and 3 and vice versa. So we see this. We have network 1 here, the internet, network 3, and then a router of network 2. So let's say copy image. Where is my rough work? I don't even remember where the last one was, which is fine. Who cares? Okay. It's not fetching, it's fine. So basically, let's say network 1 is Amazon, network 2 is Google, network 3 is Facebook. Let's see how they connect to each other. But interestingly, see network 3 has printer, laptop, and a cell phone. All other, this one has like a proper server, this one just has computers, right? So let's consider a more detailed diagram. The internet would be millions of routers and billions of devices, right? The internet below is a tiny subnet of the internet, or the network below is the tiny subnet of the internet. the mobile user can reach the web server. However, for this to happen, each router across the path needs to send packet via the appropriate link. So one office user or one mobile server, if they want to reach the web server, they have to take the proper path to reach, right? Because remember, there's only there's time to live, right? Number of hops a packet can do. So they can't just take any connected route. If the packet from here, let's see if this now is working. Okay, yeah. This time to live also is decided in very first few tries, right? A proper packet should be able to reach in these many tries. Those all maths happen in the very first one, right? Let's say when packet being sent from this user, the TTL is, let's say, 5. Here 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, 7, 8. You can't do that, right? It will die here almost. So that's what they're saying, right? The network below is a tiny subnet of the internet. The mobile user can reach the web server. However, for this to happen, each router across the path needs to send the packet via appropriate link, right? Obviously, there is more than one path. That is the route connecting the mobile user and the web server. We need a routing algorithm for the router to figure out which link to use. The routing algorithm are beyond the scope of this room. However, we will briefly describe a few routing protocols so that you can become familiar with their names. That's actually good because routing algorithms, proper one, right? People do PhD on it. So even for me, it's very hard to put. But I know just these basic ones, which just by name you should remember, and you will be able to figure out what purpose they do, right? So first one is OSPF, Open Shortest Path First. So OSPF is a routing protocol. Bro, this kind of good for me. This might come in the interview. Oh yeah, easily. These things are 100% something that can come in the interview. Especially for somebody new. These are something that can 100% come in the interview. So OSPF is a routing protocol that allows routers to share information about the network topology and calculate the most efficient paths for data transmission. It does this by having routers exchange updates about the state of their connected links and networks. This way, each router has a complete map of the network and can determine the best route to reach any destination. So in this case, all routers share information about their network topology. So basically how it was working, here is, let's say, the internet, and there are small routers. Okay, so let's fill this one with so we have all these are routers, right? And these are servers, the squares, right? If you go back, right, it says that each router shares the network topology and calculate the most efficient part. They exchange updates from the state they are connected to links and the networks. So what happens is, let's say the router A will be in chat, right? In chat with router B, and this router B will tell router A that, hey, I'm also connected to router C. And router C, let's say, is having Microsoft server, right, connected. Router B itself will have Facebook and Google, and this one will have AWS, right? Router C will know, okay, A is here connected to B, and what B has is Google and Facebook. These things are a sharing of information, and C able to see what B is connected to, and what A, if I want to reach AWS, has what this router is able to do. There is certain limit to how many routers they want to do, right? So there are certain limits to it, but that's how, because I know what my neighbor has, I know this neighbor, my neighbor's neighbors, who is that, and this will keep on continue. So, and hence, next one is, does that make sense, OSPF? Where if you guys are able to understand that basically the routers share information about their own topology, right? What are the paths they reach, and also updates about their state of their connected links and networks. So what the routers are connected to. Yo, Idor, what's up, bro? A very good afternoon to you, man. Or good evening. Nothing much, man. Routing protocols today. This is actually interesting, though. Okay. I think if you want, I can... I will try to come up with something better for this one too on the weekend. I just have to like focus. Yeah, closer, like the router which is closer, like you get all the links information. For example, it actually happens in your life too, right? Yeah. Let me give you an example. Hey, this is me. This is me. Right? Now, anyways, have a nice day. Oh, okay, nice. Okay, sounds good, bro. Let me know how it is. So, let's say this is me, right? And this is a real life example. You guys have watched this, right? This is me. I have a friend named, let's say, Rover or Wrench, right? I got you guys, Rover, Wrench, right? I have you guys. And then on this side, let's say I have my brother, right? So now you guys know what I do. But let's say we are having chat, you will know what my brother does too, right? You will have an idea what my brother does. You will have an idea what my brother does, right? Let's say my brother is a lawyer. And my brother will know what my friend does, right? Wrench or Rover, what they do. What they do, let's say they are hackers, right? Or in case of Rover, he's also a dog trainer, right? My brother has kind of an idea, right? What my friends does, and you guys have an idea what I do. Let's say software engineer, and what my brother does. Now, if you need a lawyer, you can contact me because my brother is a lawyer, right? And I will contact my brother. And my brother, let's say if he needs hackers or if he needs a dog trainer, he knows he can just contact me, right? Because I can contact you guys. I told him about you guys, right? And vice versa. You guys need him, you tell me, and I tell my brother. Does that make sense? This information, how things are passing out now? Like that's exactly, you guys are basically routers sending a packet through me so that it can reach my brother. Same with me. My brother wants to send a packet to you guys through me, and he knows what I am connected to. I don't have no. I might know what your parents or your brother or your friends does, right? But my brother won't know much about that, right? I do. So once it reaches me, that's it. So at most two nodes are connected, like many nodes can be connected, but connected to a node. Yeah, basically. But answer is like there's not necessarily two, right? Certain amount, whatever they said. There can be more. There can be more, right? There can be more. A router is connected to so many more routers. Two is just an example I'm taking for myself, where I don't want to draw like hundreds of routers right now. Imagine like a Google router will be connected. So a Google router would be like that piece of yeah, okay, so that's good. Yeah, but the Google router is like almost 100, a house as big as a house, right? As expensive as a house almost, or 1 kg of gold. It would be that expensive. Sheesh, that actually is true, and even more expensive. Yeah, so if you get the idea, that's what this algorithm does, right? If you read through it again, routing protocol that allows routers to share information, allows us as humans, we share information about our own career and what we can do and blah blah blah, but also routers exchange updates about the state they are connected to, my friends and my family members jobs, right? And who I'm connected to. So that's what OSPF is. And actually, like, I will say this. Yeah. Okay, that's good. And even actually, like, I will say this. If you're in interviews, use these type of examples, right? Like the one I gave, and that actually will show that you understand these things. Yeah. Those are hard. Like, remembering the name even for me is kind of hard, challenging. So, very, like, true. And, excuse me, a genuine problem. We have to figure it out, right? We have to memorize somehow. Maybe create a game, create a song. Ask AI to create a song on this. You might hopefully remember. Let's go to algorithm number 2, EIGRP, Enhanced Interior Gateway Routing Protocol. So EIGRP is a Cisco proprietary routing protocol. You won't that combines aspect of different routing protocols. I don't, given they are proprietary, I know they others can't use it without Cisco's permission, but I don't know if the algorithm is much out in the public. So this one combines aspect of different routing algorithms, which is great. It allows routers to share information about the networks they can reach and the cost, like bandwidth or delay, associated with those routes. Routers can then use this information to choose the most efficient path of transition. So basically, our bread and butter of this is routers to share information about networks they can reach and cost. Hey, in this example, right? Not only you will have information about my brother's like profession, but okay, how cost, what is the cost to, right? Cost in terms of, like, in this case it's about let's say money, right? What it costs. Same with you guys, he will have an idea about your cost, right? And that's how it is. But like, it's this one is way more different because it's using good trying to use the good parts of all the other routing protocols, right? They created that, and that happens in even, I think, in Python or Java, where we use two sorting algorithms to sort things. So that's their inbuilt algorithm. So that's basically it. So EIGRP is similar to OSPF, right? Sharing information about other networks and how much it will cost. BGP is a big one. Why? Because this is what is used with the big routers, the big routers, the one connecting, let's say, New York to Chicago, Chicago to New Jersey, New Jersey to, like, let's say, Vancouver, Toronto. Those big cities are connected to these ones. These are like the highway protocols. BGP is the primary routing protocol used on the internet. It's the big one. It's the more important one, right? in terms, because this is how you are able to talk to me. It allows different networks like those of internet service providers, like your basically the people you pay internet to. Either it could be Telus, T-Mobile, Rogers, Geo, Airtel, all those guys, right? Vodafone. So it allows different networks to exchange routing information and establish paths of data to travel between these networks. Crystal around the like this algorithm like, oh, okay, but there's so many algorithms at this point. But I think, like, remember, BGP is something you have to remember. This is one I will say out of all these, like OSPF is big. These all four are important, but like BGP is like very important. So BGP helps ensure data can be routed efficiently across the internet, even when traversing multiple networks, right? So BGP is an algorithm. It's not like this one is about. Now I'm creating basically cities at this point. This is New York, right? I should have gone circle, but it's okay. And let's say here, New York can send information back and forth from, let's say this would be Canada. Yeah. Might as well download that game. India. And let's say Sri Lanka. So BGP is an algorithm that can help connect New York to all the way to India, and also, if you remember, routed efficiently across the network even when traversing multiple networks. This also makes sure it reaches Sri Lanka. This is what BGP is. So this algorithm is, I cannot stress, they don't talk much about the algorithm itself, how things are working, but all they say is exchanging routing information and establish paths for data to travel between these networks, the one which are of ISP, the biggest, the internet providers, right? How data is traversing, how Geo in India is talking to, let's say, T-Mobile in US or Vodafone in UK, right? So those are the things. And the ISPs, these ones, the one that connects the world, right, are very few in number. The one that connects the actually like big continents. Sorry, my nose. Next is RIP, Routing Information Protocol. Again, this is a good one they ask. RIP is a simple routing protocol, often used in small networks. Routers running RIP share information about the networks they can reach and number of hops required to get there, right? So we'll talk more. As a result, each router builds a routing table based on this information, choosing the routes with the fewest hops to reach each destination. RIP simply is, sorry, my nose is a bit not the best. Destination hops. Why hops is important? Hops is basically your TTL, time to live, right, for your packet. So let's say if I want to reach Facebook, I want to reach, let's say, somewhere in New York, right? All that information, and I want to reach Google, right? It will have number of hops for Facebook, let's say, would be 21 for its best path. New York would be, let's say, 40. Google would be 8, right? It will have this information ready. That's the whole job of this one, so that all the things, the minimum path, what your TTL should be, is already there. It's good because let's say if my computer is connected to this router with all this information, when I'm sending like data through this router, my computer will already know how many hops it should design or put into that packet. Okay, so which routing protocol discussed in this task is a Cisco proprietary protocol? I just did it because I know like this you guys might be still processing what's happening. Do you guys like understood? Is there any of the algorithms you want to go over, or I think maybe I can do later. I can go a little bit extra over the weekend. This is something you guys can put in my backlog. Put in the suggestion ones for the weekend, because I can then draw properly. Okay. So if no doubts, let's move to NAT, our last task, task 6 of this. I would like a ground up series on networking. Yeah. Networking protocols, I will say this, is a very interesting topic. Is a very interesting topic, not going to lie. And if you understand like networking itself, just networking so much to a level that you can be better than some people who have been in this industry for almost 5-6 years. Because I know some people who are really good at their hacking job, right, or their security job, and their biggest strongest point is all networking. Maybe we could do it as a group if enough want, like Cisco Path or something. Yeah. I think that's a good one. And Idor actually recently did his Cisco some small certificate. So NetAcad. Yeah, this actually is a good one. Addressing and basic troubleshooting. Yeah. 100%. We can do that. We should have like a yearly plan. Excuse me, I'll just drink some water. What I was thinking actually, like, to set up a path or like set up a group in the Discord for a year before 2025 ends, right? Yeah. The visual learning of networking will help me a lot. Oh yeah, big time. Quick also thing is, I was thinking to create like in the Discord, right? Oh, nice. That's cool. I want to create like a space, let's say the goals one, right? Just like we have these ones. Thing with that is you have by the end of 2025 to put your goals, right? And stay accountable to it within the group. Discord chat anxiety. Like what I was saying is you have till 2025 put whatever goals you want, right? After, as soon as we have 1st January 2026, we are going to disallow any text or any, we'll just stop that and just lock that channel if you guys want. And staying what's this called, staying accountable to each other, we can do that, right? Hopefully that if you guys want, we can do that. Okay, let's do it now. Let's go for our task 6. I think we should set it for 6 months. We can, sure, yeah, like we can do a repeat one after. Yeah, okay, we'll discuss. I think we can discuss for sure. We can discuss for sure about it. It'll be nice. Okay, so as discussed, now let's go over task 6 though. That's something at least we have in our hands. So let's do that. As discussed in the networking concepts room, we calculated that IPv4 can support a maximum of 4 billion devices. How it was? Do you guys remember that? Why it was 4 point some billion devices. If you remember, IPv4 is 4 of these octets, right? And I think it was 2, 8, 16, and then 24, 32. 2 to the power 32, what was it? This is some 4 billion stuff. Why 32? Because it's 8 zeros or ones, right? 8 bits, 8 bits, 8 bits, right? So 2 to the power 32. And this is 4,294 million. This and this. Hundreds, thousands, millions, billion. Yeah. So, hopefully you remember this, right? 4 billion devices can be connected. With the increase in the number of devices connected to the internet, from computers and smartphones to security cameras, washing machines, IoT devices, sensors, blah 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 blah, it was clear that IPv4 address space would be depleted quickly. One solution to address the depletion is network address translation, the NAT. The idea behind NAT lies in using one public IP address to provide internet access to many private IP addresses, right? Just like what I was saying about your house, right? There IPv6, but also this NAT is actually used, right? In other words, if you are connecting a company with 20 computers, you can provide internet access to all 20 computers using a single public IP address instead of 20 public IP addresses. Note, technically speaking, the number of IP addresses is always expressed as a power of 2, so 2 to the power something. To be technically accurate with NAT, you reserve 2 public IP addresses instead of 32. Consecutively, you would also have saved 30 public IP addresses. Basically, let me explain in very simple terms what they are doing, right? If you remember, we had a home. We are rich people, right? I'll draw it like this. We had a home, and in this home, we had so many people. We had, let's say, parents, kid 1, kid 2, and let's say grandparents, right? So, whenever we wanted to send a postcard, we want to send something, right, through post, what we'll do, this is like a gate here. Let's say I've done a terrible job in doing this. This is, let's say, our post box, right? This is our post box. What we do, if we ever want to send data or send postcard through this, through to the world, right? Through this post box, all these people, right, will send a card here, right? And from here it goes to the world. And if somebody from outside wants to send, they will just send the postcard here. It will be stored in here, and they can just collect from here. Now, the whole in outside world, they just know that there is a device or there is a person who they want to address that lives in this house. It could be the father or mother, grandparents, kid 1, kid 2, right? They don't know who lives in room number 1. They don't know who lives in number 2, 3, or 4. All they care about is that this person we want this packet to be sent lives in this specific house, right? So instead of having, let's say, 1, 2, 3, 4, 4 different public addresses. We just have one which is of this red box, and that itself serves the purpose of these all 4. That's how networking in real world with the help of NAT happens. Because if you can imagine properly, or you probably know where I'm going with this. If I have a device, let's say an iPhone here, kind of, yes. If I'm not wrong, yes. Yeah, inside a house is 192 whatever. That's exactly what this is. NAT. That is NAT. Yes. So we have iPhone. Let's say we have a server inside our house. Let's say we have a computer, right? We have a computer, a PC. Then we have, let's say, a camera, whatever. We have like so many devices. Even in my house, I think if we talk about internet, I have 1, 2, 3, 4. I have, let's say, 6, 7 devices, right? So 4 is a very modest number. Now, if the iPhone, the server, the PC, the camera, right, wants to send data to anyone in the world, right, what will happen? They will send it to a router inside the house. The router here, they will send that. All the packets will go to this router in the house, and this router will send it to the internet, right? And if anything from the internet comes, will come to this router, and based on again the IP addresses and the MAC address which we were talking about in the last this room and the previous room, it will send them back based on information inside the packet. If it belongs to the server, it's sent here, IP, PC, or the camera. And that's how basically this is NAT. This is NAT, where we have one gate to open to the whole world, but inside we can have as many as rooms, gates we want, so that there's internal communication, right? So technically we saved 3 IP addresses because we just are using one that belongs to this router. That's the whole summary of NAT. Not a hard thing to understand, but this is a very important thing to understand, because this is basically what subnet is also, right? This is how a whole world is. This is because this is not just your case, right? This thing, right? This house thing, this is not just your case. This is the whole world case. And what does the whole world do when brought together? They form the internet. So everyone having this same setup, have the same setup at their house. Even Google has the same setup at their own data centers, right? There are multiple servers in their one. So remove this phone, PC, and camera, put server, same thing, right? The whole world, same topology. So internet is a network of networks. Unlike routing, which is the natural way to route packets to the destination host, routers that support NAT must find a way to track ongoing connections. Consequently, NAT supporting routers maintain a table translating network addresses between internal and external networks. So it will say, okay, my iPhone is connected to Google. It will keep an eye on those. Okay, this person is sending this packets to this network, right? Generally, the internal networks would use a private IP address, or 192.1, the thing you were mentioning, Idor, right? While the external network would use a public IP address. In the diagram below, multiple devices access the internet via a router that supports network addressing. How do you say the full form? Network address translation. In the diagram below, multiple devices across the internet access the internet via a router that supports NAT, network address translation. The router maintains a table that maps the internal IP address and the port number with its external IP address and the port number. So my device, my IP address, private IP address, right, for my iPhone, and there is a port number, let's say 123, will be connected to Google's multi-million dollar data center with its IP address and the port number. For instance, the laptop might establish a connection between some web server. For the laptop perspective, the connection is limited to its IP address, right? So the laptop will say, okay, my IP address is this, TCP source with the port number this. How the web server will see this connection as being established from 2123.4.5. What is that? That's the router one, right? The web server which is on the internet will only see this one address. It won't see the internal one, laptop, phone. It won't be able to see that, right? Like just like our packets don't know if somebody from the outside is sending what's this called postcard to, they send to our address, not to our room. As shown in the translation table, the router does this address translation seamlessly. Yeah. Okay. And going out quickly once more because I want to stress how important this concept is. I feel every concept is very important, but that's different. So let's say Google, not the right one to choose. Google, right? Will see only this address 2123.4.5. That's all it sees. So it will send packet here and receive packet from here. Whereas your router knows what the Google's IP address is, but it also knows what your address is. And let's say here, based on the port number, right? It will be able to tell, oh, if the packet is coming from, let's say, to this port, right? To this port 19273, that means this will go to the laptop. And thus, basically, your NAT does. Your router is basically your post box, right, outside your house. And it can like do all the jargons of sending and receiving packets. In the network diagram above, what is the public IP address that the phone will appear to use when accessing the internet? 2-row limit on the Windows? Or like because of this? Oh, okay, I can do that. I don't know. Sure, boss. I'll do that. Okay. So that actually would be nice. Oh. Okay, quick question last now. What in the network diagram over? Oh, me personal limit. Oh, okay. I'll try that. 2 of these are basically like as 3 of these. Like if you see this one, these just happen to be like as we start. Like so 1, 2, 3, 4, 5. So like just for streaming, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 are just for streaming. It's better than before, man. It's better than before. Yeah, then the browser tabs. Oh yeah, you should not see my other browser tabs. Yep. That's true. I love waking up 6 in the morning, 6:30 in the morning, just so I can get roasted by Rover. Oh, that's. I know what you mean. It's like too many things I should not have. I think Wrench Rover took your job today for roasting, man. I should not. I just should just not use this command, right? Which shows all the tabs. I should just not do that anymore. Uh, Man, that's funny. Okay. Okay. Let's continue with our session, I guess. In the network diagram above, what is the public IP that the phone will appear to use, lads? What is the IP? This is something you guys can answer. I know you guys got the potential. So this phone, what is the IP, public IP of this phone? Rench, you have to answer this, bro. Rover, you do. X.5? Oh, yes. Yep. That is correct. Good, sir. 212.3.4.5. Because Google don't care what is your public IP address. It just cares our IP of the router. Oh, yeah? Assuming that the router has infinite processing power, approximately speaking, how many thousand simultaneous TCP connections can it maintain? What? How many thousand? Oh, so how many IP addresses it can maintain? Remember, like if it has unlimited power, but there is only limited amount of IP addresses. So what's the answer, lads? I think this one 65, boss. Because it's not you are right if it was IP address, right? IP address. But remember, it is port number as well. Port number. IP address can be 4 billion, but our cap is not because of IP. Our cap is because of the port number, which is 65535. Right? So 65,000, approximately 65,000 IP addresses can have, or connections it can maintain. Does that make sense a little bit? Because it looks for two things. When it's making this internal and external network, it is looking for the port numbers. The time you reminded yourself of total port numbers, or okay, total port numbers was 65535. Yeah. Yeah, probably I looked it up. Yeah, I don't remember. I probably did look it up. But yeah, like the bottleneck here though is not the IP address, it's the port number. That's why it says, yeah. Yeah. My way of yeah, because my way of remembering is in the power of two. So I know the reason how I know with this like 6 to the power 32 is because of the IP addresses, right? But if I have to remember the port numbers, it's 65535 35 of 36 minus 1, and that also is something to the power 10 20. I think that's 10 to the power 16. What is 10 to the power 16? Or 2 to the power 16? Yeah, 2 to the power 16, right? And remember, the first one is already a special one, right? It's booked. So minus 1 of that. 2 to the power 16 minus 1 gives you 65535. Everything is zeros and one, lads. My brain just sometimes just works in this way faster than this way. I don't know why. I'm a gone case. I don't know why I think like that always. It's fine. Okay. Now, this room introduced various protocols that we constantly use, but you guys got the idea why it was 65, right? Rover, that makes sense though, like why it was 65, is that clear? Then I want to move further, if that's clear. If not, we can just go over quickly again. Okay, good. So this room introduced various protocols that we constantly use directly or indirectly. We have covered ICMP, DSCP, ARP, NAT, and routing. Although we use the internet daily without coming across most of the room's acronyms, these protocols are foundation for a functional network, right? Click on the view site button to access the related site and follow the instructions, right, to get the flag. Okay, which protocol do we need? As we have learned in this room, different protocols and techniques are used to solve various problems. In this exercise, we will help this computer get the information it needs. For each question, we need to select the protocol that best helps answer the question. Let's start. This is not. Okay, let me make it a bit. Okay. I want to obtain. This is good, like you guys can still see it. Like it's not too small. Or is it too small? Should be good, right? Okay. Let's start. Let me know if it is okay. I want to obtain an IP address to use and communicate with other host on the network. What should I use? So you want to obtain an IP address, right? And communicate with the other host. What should be it? Come on, lads. You answer. You guys need to answer this. So what is the answer for this, man? What is the answer? How will I know? Rover. So ARP, right, is to get the MAC addresses of all the people in the system, right, in the network you're connected. DSCP is to connect to the router, right? ICMP is used to ping somebody to see if you are able to reach a particular server. NAT is for local one. You answer yes, you answer you answer yes. And network address translation is for private, how we can save the IP addresses. So which one of them is the right answer, lads? I move no further till you answer. Do you guys understand Rover? Is that like Rover wrench? Yes, sir. DSCP. This is the one you guys use to connect to the router. The next one. Okay. Oh, we are already on next. Yes, it also assigns IPs. Yes. I want to find another host MAC address on the network. Which protocol? Let me see this. Which protocol helps me with the MAC addresses? ARP, DSCP, ICMP, NAT. Go host, what's up, bro? Yes, ARP, that's correct. Now, I'm curious about tracing the route of the packets as they travel to their destination server. What protocol would let me discover the path? So remember, there is something called traceroute, right? Traceroute is similar to ping. And what ping and traceroute use, like underneath protocol. That's the hint. Yes, sir. ICMP. Rover, where you gone? You have to answer the next one. I want to find out the DNS server and default route on a network automatically. Which protocol should I use? Find the DNS server and default route on a network. Take a guess, Rover. ARSP is for Mac. DHCP is to get the IP. ICMP is to check network strength, check about the packet connectivity. NAT is for like networks. Again, same. DHCP. Yes, sir. Rover, where you have gone, bros? Thank you so much, lads. And it is time to join network core protocols. Let's see what this one is. And I need to start posting this on my LinkedIn, man. Need to look for. Okay, another premium room. Okay, we'll start this tomorrow. Introduction DNS, who is a good one. I love this one. HTTP, FTP, SMTP, POP3, and IMAP. Okay, so this one will be interesting, room, where we will learn interesting stuff. But for today, that was it. Let me talk about what I wanted to share with you guys, right? So this is the sponsorship I have selected for next 30 days because just before Christmas we will be able. This will be done, right? 28 days. This will be done. I want to share what is important, why it is important, right? Every person who downloads this, I will share the link. Download through that link only, right? Yes, sir. Stream sponsor. Why this important, right? Every time the more game, this one I think you just use AI. I don't know how we can like develop a AI that will like play this game. I guess that'll be interesting. But we can go. The more you go, right? There is I think almost like big one, reach classic. This one, blah blah blah, to a level I think you can make 50 per new user. You don't have to download right now. Not just right now. You can download it right now if you want, right? Through the link I sent, but you don't have to exactly download right now. So, like, I don't want you guys to purchase these packs. These are not. You guys should not be purchasing these packs. I do not recommend, right? What I recommend, if you guys play, right, whatever money we make from this, and with the potential of like actually we can make, let's say, couple 100, 200, whatever money we make, we'll pool it for a good Christmas giveaway. That's all I want to mention, right? Because I believe we have this $20 ready, 8 from the previous one. I think again 15 from the previous. So we are at like, I think we are at like $45 almost for the giveaway, for the Christmas giveaway. We can go to at least 200 and buy actually like send a Flipper Zero giveaway, do a, like whatever the person wins can select. We can do books, hacking books giveaway. Something we'll decide, which I would be very excited. I'm going to play this game as much as I can for next 80 days. Just put it on the side, keep playing on the. I think hopefully it's automatic. I haven't downloaded it yet, so not sure. But yeah, hopefully we are able to do a good one. Yeah, a good Christmas. I'm actually like excited about it. Hopefully we are able to do a good Christmas and reach higher levels. One important thing though I decided, because based on what I have seen, the first use still, I think I'm based on somebody, if let's say one person or two people are doing more all the time, right? There are 4 or 5 people always doing more giveaways, like playing the games, right? Helping generate revenue. I have something specifically a giveaway planned for that as well, Just wanted to say that because I think it's important to mention that only a few people are generating or playing the games. You guys will be the one given some extra privilege, right? So yeah, that's one thing I want to mention, right? So anyone who actually reaches these levels, mention that, send me the screenshot in the way I asked. You will get like a extra bonus. Extra entries or actually like a exclusive giveaway. Actually, I was thinking a proper exclusive giveaway or extra entries, whichever you guys like. However you guys like it, you guys make the call. But this would be specifically for you guys who actually are doing those things, right? More than others. The top level I think is the $50 one, which was I saw and I was blown away. Use 6 legendary antimatter. So by the time, let's say if you reach this, right, as a user, you would have 50 plus 40, 90, 120, 145, 165, 180. You would be actually like around 200 like dollars you would have made from this game, which is crazy. Like promotion $200 for like how far, I don't know. Well, I know the first two levels, I think, which is like about $2 one, like this one, bronze, and these. If I'm not wrong, this is something you guys can do in like, yeah, this is like a 1 hour thing. Takes 1 hour for majority of the users to reach this level. Yeah. So if you guys do, right, however you guys will play, if you guys can reach this level, of if you want to reach this level, you want to play this much, you guys decide. The people who have done it, you guys will have either exclusive giveaway or something will plan something up. Okay? You guys will have the privilege, you guys will have the advantage of deciding this time more than others. Your call. So that's all I wanted to share because I was thinking over the weekend about this, like why, right, like giveaway, everybody participate, which is good, right, which is fine, but if some people are doing it, so I'll get 2 or 3 more people on it. Sounds good, man. Attaboy. Yeah, go for it, man. Go for it. Hopefully you enjoy the game too. Hopefully it's a fun game. But yeah, that's what I wanted to share, which I was like had in the back of my mind over the weekend, and I wanted like put it out in a proper way, without like being disrespectful to anyone. So hopefully you guys like this idea of like people who do more will get more, right? Yeah, that's all I had actually. Like nothing much. From tomorrow we'll start the core protocols, and for the networking one, I will if I'm not if I find some good videos, I will share this, and on the weekend I can go over those specific routing protocols you guys like. Okay. So hope you guys love that. One request for you guys, right? I have is 1 second here. Oh, thank you, man. Thank you. Yeah, that's all. Actually, I have nothing much. Okay. Okay. With that being said, lads, have a good day. Have a great night. I will see you guys in the evening for some lead code, right? I just don't mind like those ideas when you stop me from saying HTTP is not secure. HTTP. Holy lads. Yeah, thank you so much, lads. Hope you guys have a great day, and I will see you in the evening with some more lead code or die series. Till then, this is your favorite sniffer of packets, in the neighborhood sniffer of packets, signing off with another banger because of his audience and homies in the chat. Big bye. Have a good one, lads. Love you. Bye.